everyone, and we are glad to see all of you on our QAZ Days conference. My name is Vyacheslav, and I will be moderator of today's session. I would like to say that our session is being recorded and be available on our YouTube channel. During today's session, you can post your questions in the chat, and we recommend you to put your name, and also you can vote for questions that already posted. Those questions who get most votes will be asked first. And during today's session, our speaker Irina Ushakova will tell us about metrics. What are they? Why should we use them, and when do we need to use them? Irina has been working as a tester for more than 6 years and has a mathematical education and background of analyst. And she started her career as an analyst. There are a lot of successful projects in her practice, and she will be glad to share her experience, life examples, and knowledge about how to improve the level of software products. Irina, passing word to you. Let's start.
Thank you very much, Vyacheslav. Let's start. Hi all. The name of my talk is QA Metrics: What, Why, When. I will repeat some information about myself. My name is Irina, and I have worked in EPAM about 2 years. In IT sphere, I have worked more than 8 years. I started my career as analytic, and after 2.5 years, I requalified to QA engineer. During this talk, we will consider 3 questions. What are software metrics? Why measure? And when do we need to use metrics? I will describe the main groups of QA metrics, give formulas for each of them, and most importantly, I will try to prove that in the normal process, it can be counted automatically. It is not a routine process. And the main goal of my talk is to give understanding that using QA metrics is enough simple process, but it gives you a lot of benefits for your project. And now we will try to answer on the first question. What are software metrics? What do you think? What is the answer on this question? I have identified 2 basis definitions for them. Software metric is a measure that allows you to get a numerical value of some property of the software or its specifications. And the second, metric is a feedback mechanism. The metrics are the easiest instrument for controlling and predicting the problems on your projects. After different discussions, I found out that a lot of projects counted metrics only for presentations with projects to customer or for statistics. And they can present good pictures, but the project can be not so good. In my opinion, all metrics should be automatically processed, and we should get red flags from them. Moreover, the adding of these metrics should be not only after getting some problems and resolving them, but it should be added in the beginning of all projects for predicting these problems. Let's consider the main groups of QA metrics. Of course, there are a lot of QA metrics, but I will tell you about the metrics which I prefer to use or used on my previous projects. On this screen are presented 5 groups of QA metrics. And the first group is software requirements. This group of metrics will allow you to evaluate how requirements have been worked for software, identify vulnerabilities and the most complex, potentially problematic features of the software, and understand where special control is required. On this slide is presented the first metric from this group, named test design coverage. In our words, this is the number of tests per one requirement. The purpose of this metric is to identify weakness in the test coverage, highlight the risks. Of course, how you can answer me, this metric will work only if requirements are good decomposed and more or less equivalent. Of course, this is not always possible, but if you can make the requirements atomic enough, then this metric will show the deviation of the coverage of each requirement from the average level. When more the value differs from 1, when less or more tests are written for one requirement than usual. The most important thing is to pay attention to requirements for which the coefficient will be equal to or close to 0. For them, you need to consider adding tests. If the requirements are not atomic, then this metric will only make sure that for each requirement there is at least one test. For this, the coefficient must always be greater than 1. The easiest way to get the value of the metric is the traceability matrix. Having it is easy to understand which requirements are covered by tests and which are not. The second metric from this group, named degree of requirements are interconnected. The metric is calculated as the average number of links of each requirement to other requirements. The purpose of the metric is to provide a basis for assessing the timing of testing and taking into account possible risks. Knowing the degree of mutual influence of requirements on each other, you can, for example, plan additional time and cases for end-to-end testing, work out regression tests, look towards integration, and so on. The value of this metric will be from 0 to 1. 1 means that each requirement is associated with each, and 0 means that there are no interrelations. It is difficult to introduce any restrictions on the value of the coefficient. A lot depends on specific of the functional architecture technology. However, from my own experience, I can say that it is good when the degree of connectedness does not exceed 0.2 to 0.3. Otherwise, update of one requirement will lead to a chain of changes and, therefore, possible errors in a significant part of the product. The third metric from this group, named coefficient of stability requirements. Purpose of the metric is to show how many requirements that have been already implemented should be rewritten from release to release when developing new features. Of course, a completely isolated functional does not exist, but the number of new requirements should prevail over the variables 1, and the coefficient should preferably be less than 0.5. In this case, we introduce new features in 2 times more than redo existing ones. If the coefficient is above 0.5, especially if it is more than 1, then this most likely means that earlier we did what turned out to be unnecessary. The team focuses not on creating new values for the business, but on remaking previous released features. Also, the metric gives an idea of how easy the functionality of the system scales. Funny story from my life. On one of my previous projects, we received the request on a short feature. This feature consisted of several parts. We successfully passed the first iteration and started to look at the new changes for the second iteration. We opened our test cases for inserting changes and adding new test cases, and we were very surprised when we began to consistently change almost every test cases written earlier. And when we decided to calculate this metric, we took the number of changes in existing requirements, it was equal 3, and divided by the total number of requirements that should have been implemented in iteration 5. Thus, this metric was equal 0.6. This means that we would have to remake even more when we would do new. Of course, we went to our analyst with the question, how did it happen? And the most interesting, the analyst reviewed his previous notes and returned the original requirements. Thus, by measuring this metric, we found problem in the design at the initial stage. In the first group named software requirements, we considered 3 metrics: test design coverage, degree of requirements are interconnected, and coefficient of stability requirements. What is the most important metric in this group? What is your opinion? You are right. The most important is test design coverage. because this metric is an indicator whether all requirements are covered by tests or not. The second group is quality of software. This group of metrics demonstrates the quality of the software and development. And the first metric in this new group is defect density. Purpose of the metric is to assess the quality of development and correction of defects and understanding of complexity of the product or a separate model. The reasons for a large number of defects is any one particular model, coefficient greater than 0.3, can be different. Poor quality requirements, developer qualifications, technical complexity. In any case, this metric will immediately draw our attention to the problem area. This metric is very easy to configure at the beginning of a project. Just make a filter by all bugs and further on the dashboard is divided by components. On this slide is presented pie chart of all defects divided by components. From this diagram, we see that the number of all defects is 1140, and under this number we can find the number of defects for all components. This dashboard you can easily find in Jira. The second metric in this group is regression coefficient. Purpose of the metric is to show what the team's efforts are spent on. Do we focus more on creating and debugging new features, or do we have to patch existing parts of the software most of the time? The closer the coefficient is to 0, the less errors were introduced into the existing functionality when implementing new requirements. If the value is greater than 0.5, then we spend more than half the time restoring previously functioning software functions. You can calculate this metric in Jira, for example, by adding a regression label to bugs. The third metric is coefficient of reopened defects. Purpose of the metric is to assess the quality of development and fix of defects, the complexity of the product or a single model. This metric can be calculated for all software or a single model or functionality. The closer the value is to 0, the less all errors are repeated during development. If the coefficient is more than 0.2 to 0.3, it can indicate either the technical complexity of the model and the high connectedness of the requirements in it, or the bad architecture, or that the previous fix was done poorly. Last metric in this group is the number of defects in the code of specific developer. Purpose of the metric is to highlight possible difficulties in the development team, which of the specialists lack experience, knowledge, or time needs in help. If, for example, 50% of all defects are attributable to one developer and there are 5 of them in the team, then there is clearly a problem. It doesn't follow from this that this programmer works poorly, but it signals that we must understand the reason for this situation. The metric, among other things, can be an indicator of particularly difficult to develop and maintain a model, functional or system. You might think why this metric is needed for QA, but the QA time spent on checking tasks from this specialized directly depends on this metric. So we consider in this group named quality of software 4 the most useful metric: defect density, regression coefficient, coefficient of reopened defects, the number of defects in the code of specific developer. What is your opinion? What is the most useful metric from this list? Thank everybody who tried to answer on this question. Defect density metric is the most important in this list because the problem with value in this metric will give us the understanding in which area we have poor software quality. And the next important group of metric is capabilities of QA team. The main task of this group of metrics is to express its number what is capable of testing team. These indicators can be calculated and compared on a regular basis, analyze trends, observe on them how certain changes affect the work of the team. There is one of the most important metric in this group. It is velocity of QA team. Purpose of the metric is to quantify the capabilities and speed of the team for further planning the scope of works and analysis of development trends. In the formula is presented the number of story points of QA. I divide the number of story points of developers and QA. You can name it as you want. For example, penguins. The main idea that it is the number which can show you how many deals your team can do during the iteration. It is the summary of how many stories they can finish, how many customers' requests they can analyze and close, and so on. The metric allows you to monitor the speed of QA, to observe what internal process or external influence on the team can affect this speed. This metric is very important for the lead of QA team for understanding how many stories his team can take and complete. The next group of metric related with previous, the name is QA team quality of work. And I think this group is the most used group from all groups. The task of this set of metrics is to assess how well testers fulfill their tasks, to determine the level of competitions of the QA team. With this set of indicators, you can compare a team with it at the same time or with other external testing groups. And the first metric named the effectiveness of tests. Purpose of the metric is to show how many errors are detected by our case on average. This metric reflects the quality of the test design and helps to monitor the trends of its change. It is best to calculate this metric for all test suites, for individual groups of functional tests, regression suites, smoke testing, and so on. This indicator allows you to monitor the effectiveness of each of the sets, how it changes over time, and supplement them with fresh tests. If the value of this metric tends to 0 or equal 0, then this metric can either say that the product without errors, but we all know one of the testing principles. If there are no defects, this does not mean that they are not. Or in the opposite, can also say that the written tests are ineffective and should be changed or supplemented with new ones. The second metric is defect containment. Purpose of the metric is to demonstrate the quality of testing and the effectiveness of errors detection. What proportion of defects was filtered out and which passed to the release. The permissible percentage of errors that were skipped to the product, of course, will depend on many factors. However, if the coefficient is more than 0.1, it is bad. This means that every 10th defect was not detected during testing and led to problems in the software already transferred to users. This metric is the most popular and well known, so we will move to the next metric. Real time of QA team. Purpose of the metric is to increase the accuracy of planning and to monitor and manage the effectiveness of a particular team. Targeted activities include analysis, design, evaluations, testing, working meeting, and much more. Possible side things are simple due to blockers, communication problems, inaccessibility of resources, and so on. Neutrally, this coefficient will never be equal to 1. Practice shows that for effective teams, it can be from 0.5 to 0.6. In my practice, this metric was used on almost all projects. It well identifies problems on the project. This can be due to both projects' distractions, discussions with developers, analysis clients, or simply poor loading of people on the project. This value should be discussed on retrospectives. The fourth metric is accuracy of time estimation by area, type of work. Purpose of the metric is to allow to use the correction factor for subsequent estimates. The degree of accuracy of the assessment can be determined for the entire team or individual testers, for the entire system or individual software models. When higher the tester's level, then closer this value should be closer to 1. It is equal bad if on an ongoing basis the value of this coefficient equal 0.5 or 2. Respectively, the engineer incorrectly determines the estimated time, either overestimate or underestimates. And last metric is the proportion of rejected defects. Purpose of the metric is to show how many defects were idle. If a proportion of defects that were rejected exceeds 20%, then we can say that in the team is presented desynchronization in the understanding of what is defect and what is not. So we consider 5 the main metric in the QA team, quality of work group. And now my standard question. What is the most important metric? I think all of you right answer on this question. It is, of course, defect containment, the most popular and promoted metric in EPAM. And last group of metric which I wanted to consider with you is feedback and product satisfaction. It is a group of metrics showing how the product was accepted by end users, how much it corresponded to their expectations. Another important task of this group metrics is to show if users are satisfied with the process of interaction with the IT team and QA in particular. And the first metric is user satisfaction with the IT sphere service. It is a regular survey of user satisfaction with the IT service with scoring. Purpose of the metric is to show whether users trust the IT team, understand how and why it works, is organized, how much this work lives up to expectations. The metric can serve as an indicator that it is necessary to focus on the optimization of a process or to make it more understandable and transparent for users. The satisfaction indicator can be calculated based on the results of the survey after release. We collect all the grades and consider the average score. You can recalculate such a score after changes are made in the process. The second metric is user satisfaction with the product. A regular survey of user satisfaction with the product. Purpose of the metric is to determine how much the developed product being meets the expectations of users, whether we are moving in the right direction, whether we correctly determine the importance of features and choose solutions. To calculate this metric, we also conduct a survey of users and calculate the average score by calculating this indicator on a regular basis, for example, after each release. You can monitor the trend of user satisfaction. And last metric is the involvement of stakeholders. Number of initiatives and proposals for improving the process and product received during the iteration by stakeholders. Purpose of the metric is to determine the degree of participations of external stakeholders in the work on the product. Having such metric, you can navigate where you want to get feedback so that you do not encounter with problems and misunderstandings. Interesting initiatives coming from all stakeholders. This may be ideas from the side of business or users on the topic of simplifying the product interface, expanding its capabilities. It can also be offers from the infrastructure or a support team regarding the technical aspects of the system, reliability, performance, installation speed, performance monitoring. So we consider 5 groups of metrics. software requirements, quality of software, capabilities of QA team quality of work, and feedback and product satisfaction. And now we can answer on the second question. Why measure? The answer on this question we have already received from our previous question. There are three major reasons to measure: understanding, predicting, and controlling. Tom DeMarco wrote, "You cannot control what you cannot measure." All of you have or had project, your beloved, dear, to whom you wish to grow and prosper. But how do you assess its prosperity if there are no criteria for this prosperity? How can you quickly respond to problems before they become incorrigible if you do not use red sensor? How do you understand what should be improved if you don't know the source of the problem? In short, the metrics are needed to effectively manage the project, diagnose problems, localize them, fix and check whether the methods you have chosen to solve the problems really help. The section, collection, assimilation, and regular analysis of metrics allows you to create high-quality software and determine the directions for further improvement of the development process in the organization and project team, making decisions based on facts and not assumptions. If deviation from the normal value of the metrics are detected, the reasons for such a deviation is immediately initiated and the corresponding corrective actions are developed. Last question which we will consider is when do we need to use metrics? And I think now all of you can answer on this question. What we need metrics during lifetime of project? Now we will consider a small life example how to manage and to improve the quality of our project using metrics. Short story. At one company, management complained about a low quality product. The fault is testing. The task was to analyze the reasons this misunderstanding and how to solve it. Task number 1 is estimate percent of missed errors. Is it true that testers miss something? To answer on this question, we added the customer reported field in the bug tracker, marked the all bugs and counted. The percentage was a little over 5%. Is it a lot or a little? We added an additional field. It is reproduced on the release version. Each time registering a new errors from the test bench, testers checked to see if it was in the latest user version. The result for the first month is about 40% of the errors registered in the bug tracker are reproduced in the release version. It turns out that we really miss a lot. Both we form metric sensor. What is the reason of it? Percent missed errors in release version, percent user reported errors. Set a goal. Otherwise, why measure anything at all? We want not more than 10% of the errors that hit in the release version. But how to ensure this? Excessively expand resources, increase timelines? To answer this question, we need to dig further and we'll find new metric that will give an answer to this question. Add another field, reason of skipping, and we indicate as the reason why we did not get this bug before. For example, unknown requirements. Just did not know or did not understand that it was necessary. The second, did not create the test, did not think of testing it so. Not tested, the test was, it was checked, but then the functionality was broken and this area was not checked again. Of course, here can be a lot of reasons for skipping and you can add something else. The results will be different always, but they will give an understanding of which direction to choose in order to achieve the goal. And finally, I wanted to share with you the main types of metrics from bug reports, which are the most used. To summarize my talk, we answered on 3 questions. What is the metrics are? It is a measure that allows you to get a numerical value of some property of the software or its specification. And also, in this part, we consider the main groups of QA metrics. The second question, why we need to use it. Here we discussed 3 reasons to measure: understanding the situation on the project, predicting of the problems, and controlling of our projects. And finally, for answering on the question, when do we need to use metrics? Of course, the answer will be as early as possible. I hope all of you will try to use metrics on your projects because this process is simple and all metrics should be automatically processed. And perhaps if you have some troubles on your projects, you will recall this talk and will find out the decision for resolving it using metrics. Also, I have prepared for you the table with all presented metrics. Thank you for your attention, and if you have some questions, you can ask it now.
Thank you, Irina, for the very interesting talk. We have several questions, and the first question is, what metrics the project should use in case if they don't use metrics at all now?
I think that let me return back to the screen with metrics which I presented you, and I think that firstly, the main idea of all metrics it is manage your project, and I think that you need to insert maybe test design coverage metric, and of course, if your project is not new and you are in the middle of this project, then you can add maybe metrics from this table. And there are a lot of metrics which you can use on your project.
Okay, thank you. Next question is, how do you maintain requirements and test cases and traceability matrices on big projects with a lot of requirements?
Oh, good question. And of course, you will spend a lot of time on this, but it will be really helpful for you, and you need to do it, of course. And yes, you have a lot of requirements, but of course, all of us write test cases, and when you write test cases, you can move it with your requirements, and after that you can create these traceability metrics.
Okay, thank you. Next question is, have you ever invented your own metrics? And if yes, what are they?
I think that I don't remember which I created, that I created my own metrics. And I really used all of these metrics on my projects. Not all projects on one project, but not all metrics on one project, but I try to manage it, and if this metric are not was not working on my project, then I change it, and I try to use only useful metric for my project.
Okay, thank you. And next question is, who decides on project what metrics should be gathered? BA, QA, PM, customer, or any other?
I think that the answer on this question, all of them, and um, business analyst like traceability metrics, and QA, of course, like defect density maybe, and our customer uh, like defect containment metric. And I think that all members of team can insert this metric on the project.
Okay, thank you. And what extra column we can add in case if we are creating automation test metrics?
The most useful metric for automation metrics, it is of course defect density and test design coverage, and as I know, yesterday was we talk about automation metrics, and I think that you can answer on this question from previous talk.
Okay, thanks. And what is your favorite metric?
Cool question. Thank you. And I don't know, maybe it is test design coverage, because I used it at all projects, and I inserted it by myself. My team lead cannot knew about it, but I inserted it.
Okay, thanks. And the next question is, what is a good range or limit for effectiveness of test metrics?
There are no right question on this question, because you can have a lot of defects and test cases, but it depends on your project and on specific of your project and how much test cases you used on your project. And I stay this field without feeling, because there are no right answer on this question. It depends on your project.
Okay. And in agile projects, testing is a skill, not the role. Everyone, Scrum team and or developer team, is is equally responsible for the quality. Um, then how can these traditional metrics will help us? What is your thoughts on that?
In agile process, what the metrics we can use, or how to understand
How
this question?
how this traditional approach for metrics will help if we are working on in Scrum conditions, Scrum environment, or Agile?
Mm, First, my question, what is the traditional metrics? There are a lot of metrics, of course, and I presented you only short number of these metrics. And of course, it can help you to manage your process, and it can help you to find the problem before the release, maybe. And mm, the metric help you understand the problem, that you have the problem on your project, and how you can resolve it.
Okay, thanks. And we have the last question for today. Where do you take all of these mentioned metrics?
All of these metrics you can create on your project. Of course, you can use for this maybe tools from Jira and these dashboards, and you can create some filters, and after that you will put these filters to dashboard, and after that it will be created automatically. And I believe that I answer to your question.
Okay, thanks, Irina. We don't have questions, and I think we can finish up. So, Irina, thank you very much for this very interesting talk and your sharing your own experience and sharing the list of metrics and the possible values. It was very interesting and informative. Thanks all for your participating the session. If you have any questions, you can ask Irina using our Community Z platform. So thank you all and have a good day. Bye bye.